Hey, how it's going, guys? In this video, we're going to look at a newly released memory benchmark system or a memory benchmark for agentic AI or AI agents. If you ask AI engineers who are building AI agents, or agentic AI workflows, memory is one of the most critical aspect, right? And we have been struggling to design better memory, long-term memory, short-term memory, and so on and so forth. And memory is a complex thing. It's not that easy, right? And there are already a lot of tools available or open source projects available like MemZero, Super Memory, and so on and so forth. But most of those open source project or any other memory service providers, they are fundamentally broken, and that's what HaluMem, solves. And we're gonna look at HaluMem in this video. So if you look at here on my screen, I have this, of course, I have built this over here, a demo and a simulation for you to walk you through that what we really mean by HaluMem. I really don't know how to pronunciate this. Is it HaluMem, or something? But that is fine. This is a paper that you see. It says evaluating hallucinations in memory systems of agents. And nowadays we have been talking about memory hallucination. Earlier we used to talk about hallucinations in LLMs, right, large language models. But lately we have seen, because suddenly people have moved from prompt engineering to context engineering, right? After Karpathy posted or like tweeted something on context engineering, everybody started talking about it, and for all the right reasons, because context engineering is really really important when you build gen AI systems, because context is everything. And now when you're working with context engineering, there's something called context pollution. So not a lot of context is not good, right? If you are like keep on creating context over a period of time, it also start polluting. So context pollution is a term that started, getting some traction lately, and that's why hallucination becomes a problem. So this hallucine basically exposes, something everyone has felt, right? But never had the data for it. So that's the basically it's today's AI memory systems that, as I said in the beginning, are fundamentally broken. Let's say, for example, you tell ChatGPT that you like sci-fi, and 5 messages later, it start pitching you romance, right? It basically forgets. Uh, and like, let's say you mention a promotion after, of course, few chat messages, it really forgets and start telling you a new job opportunity or something. So that's basically not a glitch, it's a structural flaw in the system. They just forget, right? And that's what this paper has done. HaluMem, it's a benchmark, okay, uh, that has introduced a couple of things that I'd like to highlight over here. So if you come back on this demo, if you look at here, it says exposing memory hallucinations in AI system, HaluMem, right? There are 4 types of hallucinations they have mentioned in this paper, and there are a few operations that I like you to show, right? Uh, and the entire agenda of this video is memory hallucinations. Keep an eye on that. Actually, in the entire AI ecosystem, a lot of research are happening in that field. So this is what I was kind of saying. If you look at the 4 types of memory hallucinations, one is fabrication. It says creating memories that never happened. It starts creating those context and start putting into the memory, which has never happened. Let's say I like parrots now. System stores user dislikes parrots. I've witnessed it. You would have also witnessed, when you're interacting with ChatGPT, Gemini, or Claude, or any other model or chat bot. Error, wrong details in retrieved memories. Like, for example, user, my friend Joseph, and system remembers friend Mark. So there are some problems. Conflict, contradictory memories are also kind of coexist. Like, let's say memory one is good health, memory two is poor health, and now both active. Because you will have, at different times you will have different, like, let's say for example health, you will have sometime poor health, you will have sometime good health, and it never knows how to decay the context from that memory, right? It keeps on adding it until you really go and forget that piece from, let's say, for example, ChatGPT. So, conflict, and then omission, failing to retrieve crucial information. Like, for example, user mentions promotion, system forgets it in next conversation. Core memory operation that the paper talks about is extract, identify key information from conversation, right? That basically key facts from the confirmation. It basically identifies it and store, save as structured memory points, right? Store them and update, modify when encountering new info, right? Like update when they change, and retrieve, fetch relevant memories for context, right? Now, after reading all of these, right, the paper, if you read it, 43% of max recall rate. They have said base system only retrieve less than half of important memories. Like you can see it over here, it's very less, right? To find out the right context or information from the memory system. 62% is the max accuracy. Large portion of stored memories are fabricated or incorrect. Now, let's say your your 38% of them are not correct, right? And that is what the pollution is that I was talking about, the context pollution. Update omission. System fail to update memories when new info arrives. And this is what the paper talks about on a high level, the memory crisis. Now, I'll give you a live demo of it. I also have a live demo for four of these things. It says fabrication demo, error demo, conflict demo, and omission demo that you see. Now, here is the conversation, and on the right hand side, we have an AI memory bank. Now, within the conversation, it says select a demo above to see memory hallucinations in action. For example, let's say I do conflict. Now, when I click on conflict, you'll start saying, I'm feeling much better now after recovering from the flu. And it's, if you look at here, let me just go a little up. It says, glad to hear your health has improved, right? And how is my health status? The next question, like let's say, for example, it says, according to my records, you are both in good health and poor health. There seems to be conflicting information. So hallucination that you see the conflict, you can find out the AI memory bank. It has both good and poor at the same time, right? If you look at here, what happened in this case, the AI failed to update old memories, resulting in contradictory information coexisting in memory bank. That's what it does, right? Now, if you look at the error demo, now in the error demo, you can see my friend Joseph just got promoted to senior engineer. Now, that's great news about Mark's promotion. Here we are talking about Joseph's promotion. So I'm saying it's Joseph, not Mark. Then it says, you are right, I apologize. Mark is now a senior engineer according to my notes. Friend Mark promoted. I can see it over here. The AI retrieved the memory but got the key details wrong because it's a key value pair, right? The key is basically the name and whatnot, right? It confused Joseph with Mark, corrupting the stored information. Then we have fabrication demos. So, for example, on the I said I recently started liking parrots. They are amazing birds, but you can see it says I understand you dislike parrots. I'll remember that. Wait, what? I said I like them. So it says I apologize. User dislikes parrot. It never said it that it disliked, but anyway, it saved it. Then the omission demo. Now in the omission demo, you can see it says I got promoted to senior research scientist yesterday. Congratulations. What is my current job title? Blah blah blah. Could you tell me what you do? Because sometimes it forgets also. So you can see it over here. So this is on the live demo of it, like four types of hallucinations that we talk about, right? Uh, let's go to operations. Now, if you look at the operations here, because this is important to understand, because we said, right, when you talk about the existing memory providers or projects like mem0, super memory, open memory, etc., extraction is already broken. Top system recall only 43%, the number that we saw, of what they are supposed to. So it's a less number. And they also store tons of infabricated information or incorrect or fabricated memories, not infabricated, my bad. Incorrect or fabricated memories into the system. And updates are also a disaster. Extraction is already broken. And question answer in real time, they collapses because of all these regions, right? Now, I'll just show you over here. So if you look at here, we have extract, store, update, and retrieve according to this paper over here. So if you go up, you'll find out, and this is what I was talking about. If you look at super memory, memo based JEP mem0 is very famous. Mem0, memo super memory, right? Memory operations you can see over here. Manageability, you can see graph support. They have compared various memory system in this paper. This is a paper I recommend, guys, if you're working in the memory memory side, like I really find interest. I already have couple of videos where I have shown the entire memory design patterns, of when we are building AI agents. Locomo is the very famous benchmark, right? Locomo earlier I have also covered it, but this is we're talking about HaluMem, right? HaluMem is that what we're talking. It has different features: evaluation granularity, evaluations timing, evaluations tasks, memory type, memory update, so on and so forth. So I'll just keep going a little bit. You can see over here problem definition. This is what I talked about. This is what I talked about here. HaluMem and existing hallucination methods. I'll just quickly go up. This is fine. This should not be a problem. And you can go through the paper, guys, and understand how I have understood, and that's how I created this uh, simulation demo that I'm showing to you guys. You can see all the evaluations over here, right, for different things: accuracy, updates, question answering, and so on and so forth over here. So now coming back to it, if I run the success flow, this is how a success flow works. So if you see here, input, if you look at this, I work at OpenAI as an AI engineer, right? Output extracted, workplace OpenAI, and role is engineer. Update, workplace OpenAI role engineer output is stored with ID, and that basically saves it. Input got promoted to senior engineer. Update role senior engineer. Earlier it was only engineer. That's a thing, right? This is a memory operation pipeline: extract, store, update, and retrieve, right? Now if I just run the failure flow, now in the failure flow, if you can see here, it says I love science fiction books. The output is dislike science fiction. Now it's a fabrication, inverted preference, and that gets updated right in the database or a memory system, because memory in the end of the day, it's a file for you. Either you are having a JSON, you are having a database, or you are having a TXT file or whatever. It's a database for you. Now input, you can see the dislikes here. Science fiction is stored incorrect data, and then it retrieves also incorrect because it has saved that, right? So this is the failure flow. Now how memory operation works, you can see this is what I have already spoke, and this is the common failure point. Extractions, 43% recall rate. Half of important information is already missing, in other existing memory systems. Storage corruption, 40% of stored memory contain fabricated informations. 74% of omission rate when updating existing memories, and retrieval issues. So you can find it out over here. So this is what I also have, here in operations. Then we have metrics. Now in metrics, these are all coming from the paper. Nothing fancy over here, you can see. And this is a very interesting metrics, guys. 96.8% degradation at 1 million tokens, because people think that, too many tokens that you fit into a context window is good. It's not good. If you have more context window, it will start hallucinating. That's a normal tendency of an LLM. And that leads to the same memory principles as well. This is also a very interesting metric that you see. We have compared here with memo base, super memory, mem graph, and mem zero. Performance versus context length. You can see the multi-metric comparison, hallucinations type distribution. That should be fabrication. Actually, there's a typo. And the key findings over here. So this is basically the metrics that we already talked. Now system comparison, you can compare that with mem zero graph, memo base, and super memory. All their recall, their accuracy, their updated accuracy, omissions, and long context. Long context, like, is very, very important when you work with, larger amount of context that you have, right, or data. Super memory has the best recall at 53%, but it still fails nearly half of the time and degrades severely with the context. MemoBase has the worst recall rate at only 14.51, missing over 85% of important memory, guys, on this HaluMem benchmark. Locomo, probably you have to see, the rating legend, you can see it over here. Now, here is the presentation that I created because I wanted to walk you through, okay, that AI memory crisis I spoke about. At 50% of memory, so half of your memories that you are building are corrupted or lost, right? That's a big issue. AI fabricates false memories, right, about users, and that's why we face some problem, and it affects overall your current system. Now, what is memory hallucinations? Again, to recap it, fabrication, creating memories that never existed. Error, getting key details wrong, like getting key details wrong, like names, dates, or any other key value pair in the key that we have, the key element. The conflict, keeping contradictory memories active, right? And that's where the decay comes up. Decay is very important. Context decay. Uh, just to tell you why, because if you look at here on my slide also, right, this is a thing that I have. We talk about the context pollutions like hallucinations entering persistent memory, because most of the time you will be persisting your memory, right? And the hallucinations enter into that memory. And as I said, right, contradictory information accumulation. So you accumulate so much of contradictory information, the LLM gets confused, because in the end of the day, it just follows your instructions, right? Or whatever agents you have, you just LLM underneath, right? So that's the thing. Confidence decay over time. So that is something which I wanted to say. So context decay, information overload, context pollutions, context windows limitations, combining, they are all part of context engineering. So that is also an important topic. I will cover that in upcoming videos. But coming back to this is what I wanted to say. The stocking numbers, we already spoke about it. How memory should work. Now, how memory should work? It should be a four-stage pipeline. Extract, identifies key information, store, save as structured memory, update, modify when new info arrives, and retrieve the fetch the relevant context. This is a four-stage pipeline. That's a very transparent memory ops that you should design, right? If you're working on a design pattern, for your agentic AI memory, this is how you should do it, right? You can bring up hard constraint, specialized modules to kind of enforce some policies also for your for reducing the memory hallucination. That is something is there. Now the cascade of failure, like how error compounds, bad extraction, wrong storage, failed updates, hallucinated responses. So this is a step, from bad to hallucinations, right? This is there. Context length. I know I talked about it. If you keep on getting higher context, your recall in the memory kind of comes really down. So if you look at 1K token, 43% recall, 1 million token, 3.2% recall. Longer the conversation, worse the memory, and this is completely, reasonable. I'll say also why, because pretty similar how, you know, I will not say for all humans because we have different IQ level or different memory level as well, but if you keep on kind of you don't remember everything like what happened in 20 years back. So if you look at longer conversation or longer period of time that we have lived on this planet, similar for AI also, or the agentic AI system, longer the conversation, the memory get worse, right? So that is something to keep in your mind when you are building these systems. uh, Super memory is one of the best for recall, more than 50% they get it. Memo base is the worst, 14.5%. Mem0 and Mem0 graph is still fine, right? They are in like between 43% recall, 25% update accuracy. If you look for a balanced memory, I think super memory and Mem0 are the projects that you should look into, right? Why this matters, impact on the future of agentic AI, because I always emphasize saying that memory is one of the most important thing when you build an agentic AI system. Without memory, you cannot take it to production, for a lot of use cases, right? You cannot build reliable AI agents, cannot maintain user preferences, right? That's a problem. Cannot track project state because the state management becomes a problem, and cannot be trusted with critical tasks. This blocks the AGI progress, right? Just from a memory standpoint. Of course, there are other variables that also plays a role when it talks about when you talk about AGI. Now, the current architecture lack, I said, right, reliable correlations between operations, the operations we talked about, extract, that operation that we talked about over here. If you look at extract, store, update, and retrieve. So that is something to keep in mind. I'll just quickly go here. Now, correlations, constraints on memory formation, interpretable memory mechanisms, and dedicated model for each operation. So that is important to keep in mind. In the path forward, what is the path forward? Operational level evaluations, HaluMem is a good benchmark for you. Right? You should look at evaluation metrics that they have. Uh, User confirmation for memories also is important. I think ChatGPT has started doing it lately in their chat interfaces. Audit trails are important for modifications, and dedicated models per operation is also important. So read the HaluMem paper, guys, that I recommend. I really liked it. I read it, yesterday, and I wanted to create a video for you guys to understand, that this is important to kind of start reading and start practicing. Uh, Contribute to the solutions. The future of AI depends on solving this. That's the slide, right? Of course, this will be open source. Hello, mem. Exposing memory hallucinations in AI system. This is very fancy user interface. Wanted to explain this paper through a visual interfaces like through an UI. It doesn't really make sense when you directly go into paper and read the same thing and just show people, right? It doesn't make any sense. On this context engineering, something cool is coming. You see the context pollution, right? One bad apple kind of start polluting the entire thingy. That is there. We're going to talk about context anatomy, system prompt, message history, user preferences, retrieve knowledge, and tool schemas. There are different types of memory that we can talk about. 5 optimization strategies: selection, compression, sorting, isolations, and formatting. So this all will come right pretty soon in my context engineering video or the playlist. I'm going to create a playlist. But for now, I'll recommend you read HaluMem paper, right, and see how you can create a good memory design. Look at the memory design patterns, right? Because all the leading memory architectures fail systematically. It's not a random thing, it's like a systematic thing. The flaws start at extraction itself, right? And snowball through updates and culminate in incorrect answer. That's what you see on chatbots, right? So we are far from a trustworthy AI system or companion because today's memory stacks are really fragile. So really opaque also. So you have a look. How do you want to build the memory design patterns? I'll give a previous video link in description where I have shown how to create memory design or how to design memory basically for your different types of use cases. For summarization, it will be different. For retrievals, it will be different. For question answering, it will be different. That's all for this video, guys. Right? If you want to learn agentic AI, I will give the agentic AI toolkit link in video description. Have a look at that. If you want already built SaaS project, SaaS applications, there are 6 SaaS applications I have built. They are part of a single bundle that you can also get it. Find the link in description. That's all for this video. Right? If you like the video, hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all. Thank you so much for watching. See you in the next one.